Scientists have developed a new reusable mask that's 99.9% effective in bacterial filtration and can kill germs in 45 seconds. Nanyang Technological University researchers say the mask can be washed and reused more than 10 times. It could also be available on the market soon. The mask comprises an antimicrobial coating made from very small copper particles. It is applied on a fabric mask that attracts particles and germs. This gives users a double layer of protection compared to surgical masks. Researchers say the mask breathes better than an N95 mask, which is denser. An overseas company is using the new fabric to produce N95 masks commercially. Another local company has licensed the patented coating to be used in reusable face masks. NTU is now looking to work with local industry partners to scale up the production of its 2-in-1 mask. And for a closer look, we're joined by Professor Lam Yeng Meng, chair of the NTU School of Materials Science and Engineering. Thank you for joining us this evening. Firstly, the main innovation here is the nano coating that's made up from small copper particles. How does that work?
Okay, actually, the coatings and material is actually made up of these nanoparticles, which actually can, when come into contact with bacteria, it basically releases reactive oxygen species. And with that, the bacteria can be destroyed and killed. And this actually happens in a very short time. So this can happen within a minute or so. So this actually gives us a lot of advantage in shutting down the transmission at the source very quickly.
Professor Lam, the mask is made using this antimicrobial coating, this sort of nano coating. Are there any safety risks that are associated with perhaps inhaling or touching the nanoparticles?
This is a very good question. We always consider a dose and response relationship. We will want to minimize the risk by lowering the amount of any of these nanoparticles used. But in fact, for this particular coating, we don't need very much of these particles because they are actually very nano-sized. So they can actually coat uniformly. So regardless, there are actually clinical trials and also non-clinical studies which have been found that these particles are actually non-irritating, non-sensitizing, non-toxic, and actually safe to use. Even when it comes into contact with things like an open wound, it's actually still, it will be no adverse effect. In fact, copper has been actually used in ancient times for wound treatment, but also water-containing vessels and things like that. So the Greeks, the Romans, the Aztecs has been using them.
And the coating, it lasts for at least 6 days. Is the team working on a version that's longer lasting?
Okay, actually, the coating is very stable. It will last for a long time. So the 6 days is actually continuous inoculation. What I meant is we inoculate the mask with bacteria in the first hours and at regular intervals. And every time that we inoculate, we test, it's always a 99.9% bacteria killed. So this actually lasts over 6 days. So it lasts over like 144 hours. We can extend this test. We just have not done it. So this, what does it imply to the users? So it means that actually when you use it in the morning, when you start using a mask like that, it's very effective. At the end of the day, I don't know, 24 hours later, 12 hours later, it's certainly still very effective. So this is actually the implication to an application like this.
Well, masks that can protect us from infection of any kind, they're in high demand now, Professor Lam. When can we expect these masks to be on the market commercially?
Okay. So we actually have already, we are working with a local company in implementing these coatings on reusable masks. And also for the combined version, I mean, the combined version, which is actually the excellent filtration together with the antibacterial effect, this combined mask is actually, we are still looking for commercial partners. We will love to work with Singapore companies to bring this to market and bring it to the public. Currently, there is actually prototype available.
Professor Lam, thank you very much for sharing your thoughts with us this evening, and congratulations as well on the development of this material. Professor Lam Yeng Meng, the chair of the NTU School of Materials Science and Engineering.